This episode of CppCast is sponsored by Undo Software. Debugging C++ is hard, which is why Undo Software's technology is proven to reduce debugging time by up to 2/3. Memory corruptions, resource leaks, race conditions, and logic errors can now be fixed quickly and easily. So visit undo-software.com to find out how its next-generation debugging technology can help you find and fix your bugs in minutes, not weeks. Episode 42 of CppCast with guest Marc Valle, recorded January 21st, 2016. In this episode, we talk about transpiling to C and C++. Then we'll talk to Marc Valle from Intel. Marc will talk to us about protecting your application code from tampering. Welcome to episode 42 of CppCast, the only podcast for C++ developers by C++ developers. I'm your host, Rob Irving, joined by my co-host, Jason Turner. Jason, how you doing today?
I'm doing all right, getting over a cold. Hopefully I don't hack and cough too much into the microphone for today's episode, Rob.
Yeah, my whole family is getting over something as well. I think I'm okay today, but my daughter actually had pneumonia right after last week's episode, so we all kind of caught something after that.
Oh, that's unfortunate.
Yeah, very unfortunate. Well, at the top of every episode, I like to read a piece of feedback. This week, I got a tweet from my developer day, and he wrote in saying he just finished listening to every back episode, and now he needs us to up the frequency to 2 a week. You've made my journey to work fun. So, Jason, I don't know how you feel about this, but I'm not sure if we would ever be able to handle 2 episodes a week.
2 a week does sound like a bit, but if they want us to keep up the frequency, more of our listeners need to send us potential guests.
Yeah, that's a good point. Yeah, it's interesting because when we first started, there were some actual bits of feedback saying like, oh, can you guys really keep going at 1 a week? And I'm happy to say we're able to.
Mostly, yeah.
Yeah, we just missed a couple weeks here and there, but 2 a week, I just don't know how we could get out that much content with our focus on just C++. But yeah. Thanks for the suggestion, and like Jason said, we're definitely always looking for guest suggestions, so feel free to send us those over Facebook, Twitter, or you can email us at feedback@cppcast.com, and don't forget us to leave us a review on iTunes as well. So joining us today is Marc Valle. Marc is the technical lead for the Intel Tamper Protection Toolkit. His professional interests include tamper protection, reverse engineering, compilers, security, and privacy. In his free time, he can be found staring at the black line at the bottom of the pool, preparing for his next competition. Marc, welcome to the show.
Thanks, guys. Good to be here.
So, what kind of swimming competitions do you participate in?
Master's level. So, in fact, just this summer, I got back from, I went to Worlds in Russia, in Kazan. Oh. So the cool thing there is they've aligned that now with the Olympic Worlds. So essentially, we got to see like Ledecky break the records and stuff like that, and then we swam there like the next week. So it was pretty cool. Great experience. I've been to Russia before for work, but this was the first time it was purely, for fun. Ate a lot of great food. We also made some stops off in Estonia and Finland, neither of which I had been to, so that was pretty fun.
Wow, sounds like a great trip.
Yeah,
it was.
Awesome. Okay, so before we start talking about the Tamper Protection Toolkit, we have a couple news items to go over, and Marc, feel free to jump in on any of these. This first one is an interesting list that you found on GitHub, Jason, of different compilers or transpilers that target C and C++ code. Do you want to do a little more of an intro for this, Jason?
It's like this interesting, kind of brain candy for me to look at all these things. There's basic compilers and Lisp compilers and Python that all take your, Python, Perl, whatever input and generate C or C++ code from it. And it made me just wonder, I wonder if there's anything that could really, be an advantage in your project base to write some of it in Python have it translated into C++, and then compile it all as your C++ project. I don't know.
Yeah, some of these are kind of really off in the weeds languages I've just never heard of. I don't think we've been cursing at all on the show, so I hesitate to
right.
to drop one. But there's one called BrainF, and you've probably heard of it, which is a language that just consists of punctuation, really. And apparently, you can transpile that into C, which is interesting. Are there any other kind of cool ones you wanted to bring up?
I noticed that one of the Python compilers...
For me, it certainly makes a lot of sense.
Yeah?
I mean, it's a lot easier to sort of predict, in my mind, what the compiler is going to do, what code is going to be generated at least assembly level from C code as opposed to some weird language. So getting it into that form first can be super handy.
Well, the major downside I see potentially to this is having to debug what the compiler is outputting along the way, too, since some of these are relatively small, unknown projects.
Yeah, that's a good point.
Mm.
Okay, well, this next one is an article, just a post on Reddit, talking about a trend with Lambdas potentially being dangerous when they're included in the header file. Jason, did you want to go over this one too?
Sure. So in C++, there's this thing called ODR, the one definition rule, if anyone's not familiar with it, saying that every object, basically, or what's a good way to put it, function, instantiation, has to have exactly one definition in your code base, right? In the compiled object. But if you use a Lambda and pass it to a template, you risk having multiple things that do exactly the same thing from different translation units, but have different implementations because each Lambda, by definition, is a different type.
Right.
It's kind of esoteric, but it's also interesting because Lambdas are getting a lot more use now, and I'm wondering where this is going to go.
One interesting thing that came up in the discussion on Reddit was John Caves from Microsoft joined the conversation and says that, there might be a bug in MSVC's handling of this, and he's going to look at fixing it for the next version.
Yeah, and there's some discussion about whether the standard itself needs to be updated to deal with this problem, too.
Right. Mark, was there anything you wanted to add on this one?
The standard is tough for me. Yeah, I don't follow the standard that closely, honestly.
Okay. Well, this last article is actually also coming from Intel, Mark, and this is Visual Studio 2015 Update 1 added a new experimental feature called MPX, which is Memory Protection Extensions. And there is an article here with a little tutorial on how you can go about turning on MPX, which looks like it basically will check for buffer overflows for you. It is somewhat limited to, you have to be on the latest and greatest Windows 10 version, and you need to be using a fairly new Intel processor. Mark, is this something your team works on, or one of your? Yep.
Well, this is not something that we work on ourselves. Intel has a pretty big company, also a pretty big software organization. But this is definitely something we're really excited about. Generally, one of the we're always trying to put new stuff to help developers in our chips. But ultimately, if there's not tools to support them, or sometimes operating system support, the end user doesn't see that, or the end developer doesn't. So we're really excited to see that Microsoft is providing the first support for this. So again, to make this work, you'll need Windows 10 and Skylake, which is the latest generation of the processors. Mm-hmm. But the cool thing is when you have those, you'll be able to, even if all your customers don't, even locally on your machine, you can use this for like debugging things. It's just another way to see if things go out of range or stuff like that. There's also currently Linux kernel 3.19 and GCC 5 also support this as well. So if you're doing development on those compilers and operating systems, you'll be able to take advantage of this on a Skylake.
Interesting.
Okay, yeah, you just answered my next question, if there are going to be any GCC or Clang support for this.
Yeah, I don't know about Clang, but I know GCC as of 5 already supports it.
Awesome.
But you need a Linux kernel 3.19 because it's a combination of kernel support. There's a runtime library. There's a few things that work together to make this work.
Okay. So let's get started talking about the project your team works on at Intel, which is the Tamper Protection Toolkit. Can you give us an overview of that?
Yeah, sure. So the top level bullet points is you can use it to protect application code against reverse engineering with the obfuscating compiler that comes with it. It can also, it'll sort of create a runtime software protected execution environment where you can do sensitive operations that are a little bit harder to observe and also modify. In addition, it can help monitor software and code from tampering at runtime. So let's say that someone tries to jam a branch and change a check, like an if, to something else. We can detect that at runtime and, prevent, let's say some virus or worm is trying to change some of your code. That can be detected at runtime and, prevent that from happening. We can also use it. You can also use it to secure some kind of assets in your code, such as maybe if you have keys or passwords in the code, you can protect them in a similar fashion.
So if someone does actually try to modify your binary that's been protected, what happens?
Well, that depends on which binary. So there's two main components in the Tamper Protection Toolkit. One of them is something we call iProt, which is our obfuscating compiler. Essentially, it'll take a shared library input, let's say a DLL or an SO, and it'll create a self-encrypting and self-modifying equivalent output code that's harder to reverse engineer and tamper with. So that's one component. So if someone were to modify something in there, essentially what would happen is it would lead to your program failing to execute. It would typically crash. There's a second component as well that's called code verification library. And what that can check is you build that into, let's say, something that's protected by iProt, and it can check other bits of code in the system. Let's say just a general SO or DLL you have, that could be, C++ or whatever. And if someone tampers with that, a check from within the portion protected from iProt can detect tampering. And if it's tampered with, then you can take a specific action that's not just crashing. I mean, you could fail in a more graceful way, or you can detect it and do some different activity. So depending on how you engineer your security solution, you have a couple options.
Interesting. So you keep referring to it, as a compiler, but it starts with object code. Is that correct? Not with source code?
That's correct. So the typical use model for at least the iProt portion of the code is you would build a SO or a DLL, and you would pass that SO or DLL to iProt along with the entry point you want to protect. And it'll produce an equivalent SO or DLL output with that entry point, as an entry, but with the same functionality, but essentially it's self-encrypting, self-modifying code. So what we do is essentially we start from that entry point, we disassemble the code, we go through all possible code paths, take it into an internal representation, and then modify it in such a way that, it's harder to tamper with.
So it's not just the entry point that you specify, it's anything inside that DLL that entry point also references will also be protected?
Exactly.
Okay.
Right. All code paths starting from that entry point. So also, interestingly, obviously, if any code paths that aren't reached there just never get sucked in. So, if you have 10 entry points and a bunch of other code sitting there, and if they're never called from the one you pass in, they never even get included in the final binary.
Interesting.
I wanted to interrupt this discussion for just a moment to bring you a word from our sponsors. Do you hate it when your customer finds a bug in your code? Tired of spending ages trying to reproduce intermittent failures? At Undo Software, they know that debugging C++ can be hard. That is why their next-generation debugging technology for Linux and Android is designed for C++ users, and is proven to reduce your debugging time by up to 2/3. Embed Live Recorder within your program so that you have a complete record of your program's execution in production. Activate it in your test suite to solve intermittently failing tests, and replay it later for offline analysis. Memory corruptions, resource leaks, race conditions, and hard-to-find bugs can now be solved quickly and easily. Visit undo-software.com for more information and start fixing bugs in minutes, not weeks. There's something on the facts saying it works with C and NonPolymorphic C++ assembly. What exactly do you mean by NonPolymorphic C++?
All right. So first of all, what the fact means there is that's specific to iProt. So code verify. You can verify and protect from tampering things that are pure C++ with no restrictions. However, the things that are protected specifically by iProt, which are also obfuscated, that also go into this protected environment, those things have some limitations. The basic limitations are the code cannot have relocations. It can't have indirect jumps or indirect calls. And so in C++, if you're doing something with polymorphic classes, you're going to have a vtable. And so it's going to have a call through a pointer. And so at compile time, we can't disassemble your binary and figure out where that's reaching. So in other words, if it's calling, some virtual function, we don't know where that is at the time that we're scanning the code, or at least we can't figure that out. Now it's hard to figure out. Theoretically, with some data flow analysis, it could be possible, but we don't have that support yet in our code. So That's what I mean. That's what we mean by non-polymorphic C++. So if you use C++ that doesn't have relocations, doesn't have indirect calls and jumps, then it will process it.
So iprot would work, but it wouldn't protect everything that the user might expect it to protect because you couldn't trace all the way down.
Right, but it wouldn't exactly. It wouldn't. iprot would fail to essentially process it, because essentially what we're trying to do is you emit equivalent code that functions the same as the input. But if it can't trace down, it's going to get to that code and it's going to get to this indirect call and it's going to say, I don't know what to do here, error. So typically your typical use case of this is you would refactor your code if it's with C++. Generally what we do ourselves is we just refactor it to C. But we don't put all our code into the iprot code. We put the things that are sensitive typically into it. So typically what we'll do is we'll find, the bit of code that we want to protect, the sort of root of trust. We put that into, like a C module. And then from that we spider out with code verify to detect tampering. So things that need to be protected from observation, we put inside the C module, and things that just need to be protected from tampering we'll often put inside these C++ components that are outside of it.
Okay.
Now, you talked a little bit about protecting, certain assets. Is that part of iprot, or is that kind of from the rest of the toolkit?
Well, it's both. So iprot will protect assets from being both observed and modified, so assets like in code. So let's say, again, you wanted to have some simple encryption or something, and you wanted to embed a key. I'm not suggesting this is the best way to do something, but let's say you want to embed a password into your code for some reason. If you wanted to do that, you could embed the password into, let's say, a constant static in your code in iprot, so that in your DLL, let's say, and then process that through iprot. And when you do that, the way iprot works is, if it didn't do this, I should say, you could just take a disassembler, do a dump bin, take a look at the binary, find the string, real easy. If you pass it through iprot, it's much more challenging for an attacker to be able to extract that string or password or whatever. So that would be an example of how you could protect an asset with iprot from observation.
If you don't mind if I go back for just a second, if you can protect anything that's C or assembly, you can certainly do things that behave like virtual table calls in C or assembly, like C++ does. So can you encounter the same kind of failures in those languages?
In C, absolutely. So if you essentially if you were to write something that is a call through a pointer in C, then we would essentially flag an error, say, hey, there's an indirect call here. So okay. Yes.
Interesting.
So we talked a little bit about C and C++. Does iprot work with other compile languages like Fortran?
So we've not validated it with that. In theory, any fully linked binary image that you can emit that doesn't have any indirect calls, indirect jumps, or relocations, we could theoretically process it.
It kind of sounds like, I'm sorry, go ahead.
But we haven't validated that, obviously.
Okay. Do you rely on the C ABI in some way, like being able to look at function call names and that kind of thing, since you have to provide an entry point?
Only for that. Actually, it's not really the C ABI so much as just the symbol table that we look at in the image. So we are relying on the SO format or the DLL format. The way we require it is we actually require the entry point to be an exported function. So we don't have the capability right now to give internal functions that aren't explicitly exported by the DLL or the SO.
Okay.
So what operating systems does this work on currently?
So the tool itself works on Windows host only. Currently, the targets can be Android or Windows.
Oh, okay.
In theory, I suppose Linux would work, but we don't advertise that, and we don't officially support that. But certainly, internally, we've had it work just fine on Linux SOs.
Okay. Yeah, I was wondering about that because isn't an Android library very similar to a standard Linux SO?
Yeah, very similar. In fact, early on we actually used Linux to do some of our validation before we actually were validating on Android. But again, according to the official support, it's Android and Windows.
Do you have plans to officially expand that support?
Yeah, I think that it's primarily going to depend on customers. I think that primarily what we're targeting right now is those developers that are targeting Android, because they have some in the mobile world and stuff like that. There's a lot of interest in protecting assets you put up on the App Store or whatever or Google Play or whatever. But certainly if there was some requests for that from customers, that's certainly something we could really easily do. We're just sort of looking at the market right now. We're in beta, so that could certainly be, if a lot of people clamor for that feature, it's certainly something we could do.
So currently it is a free tool, correct?
Right. The current beta right now is free. There's a link you can download. It's Intel software Tamper Protection. I believe that we can provide a link with the podcast or whatever.
Yes. Yeah, we can put one up on the show notes. Okay.
Yeah, the current version is free.
Do you know if that's going to change when you come out of beta?
I don't know for sure. My understanding, I mean, a lot of it depends on sort of what the business side, wants as a goal for this. My understanding is it will be a charge for a fee product once it's released, but that's not officially decided yet. I think that's still TBD.
Okay. Are there any downsides to using the protection toolkit, like a performance impact, anything like that?
Yeah, absolutely. I mean, obviously what's happening when this thing is running is we have self-encrypting, self-modifying code. So as it's operating, some small portion of the code comes in the clear and everything else is encrypted. And then the next phase of execution, that port becomes encrypted and something else becomes decrypted. And so obviously this is a, performance penalty. And, that's tunable with options to the tool. So you can decide, how frequently it mutates, how frequently these transformations occur, how big the window is, when they happen. So hopefully you don't, if you have a performance sensitive section of code, you're not going to do a lot of mutations in a very tight loop. So we give the capability to the developers to sort of tune that, but it's certainly, a key aspect of actually deploying this in a real solution is you want to, understand the security versus performance trade-offs, because you can make it very secure, but that can kill your performance, or, you can make it very performant, but you have a lot less security benefit.
So you've mentioned several times that it's self-encrypting, self-modifying code. Do you have any problem with virus scanners on Windows host flagging your binaries as doing bad things?
So we haven't really run into that yet. However, we can certainly imagine that being an issue. And in fact, we are working with some antivirus vendors on technologies to mitigate or minimize that sort of impact to our customers. Something like saying, hey, this is something that's protected with iProt, and as a result, or as an Intel tool. So as a result, if you see this, just heads up.
Interesting.
Bring it back to Android for a moment, since that seems to be one of your primary targets. Is it only Android x86, or is it Android ARM as well?
Well, we only support x86 right now. So currently, it's very dependent on the instruction set. That obviously we have to do a disassembly and stuff like that. In theory, sometime in the future, we could potentially make ARM work. I mean, one of the issues with ARM, besides just the instruction set, obviously, is we have to be able to support self-modifying code. And due to the way the caches are set up in in ARM, that may be a little bit of a challenge. But, for now, currently x86 only.
Yeah, it does sound highly CPU architecture dependent, like it would be a complete rewrite almost for another CPU architecture.
Well, not necessarily. I mean, again, not to get into too many details, but a lot of the parts of the technology have nothing to do with the specific instructions. I mean, we have, actually the tool itself is written in C++, and, there's a lot of things that have to do with, graph manipulation and stuff like that, and matrix multiplication and, Feistone networks and stuff that are completely unrelated to the instructions. I mean, the components that do the reading and the writing of instructions are a relatively small portion of the overall code.
Okay.
Is there anything else we're missing that we haven't brought up yet, Mark?
Besides the website, there's also some pretty cool tutorial video up on that website that I think I can give you guys a link to. You can sort of attach. It's a quick, like sort of a hello world for the tool. And so it'll basically show you, I think the example was like in Visual Studio, you go quickly and, create a simple, obfuscation or whatever of a really small bit of sensitive code. So it's kind of nice to look at it. I think it's something like 5 or 6 minutes long. It sort of gives you a feel for how it's used in practice. Right.
Yeah, we'll definitely include that link in the show notes.
Since this is a C++ podcast and you said the tool is actually written in C++, are you guys doing anything cool with C++, pushing the language in any interesting ways to write this project?
Well, I don't know so much about pushing the language. I mean, we're trying to be, I try to be really cautious. I mean, there's some really great things about, so a lot of C++11, certainly. A lot of the great, it's very strongly more in that style. Very, very low on Lambdas and things like that generally. I mean, we try and, things that are really nice features, but things that are also easy to grok for the people reading it. I mean, my experience is that things like Lambda are great for the person writing it and horrible for the person reading it in a lot of cases. So, we don't want to do write-only code. But certainly one of the things that we do rely on a lot is So some of the BGL stuff is one of the things that we rely on. The Boost Graph library for graph code, because since there's nothing in the standard library for that, so that's certainly very handy for some of the control flow representations that we have.
Interesting. Do you have any particular then pet peeves? You mentioned Lambdas. Anything that you're like, man, I wish this would just removed from the language altogether?
I wouldn't say that. I mean, I think that a lot of things that I like about the language, I mean, or at least I really like what C++ 11 did to the language. I mean, there were a lot of problems before with, sort of the idioms for memory management, and I think a lot of the, using a lot of the things like the unique pointers and things of that nature have really made the code a lot clearer and easier to follow. So I'm sort of happy with where things are now, but I wouldn't say that I'm sort of a language wonk in that area. My area of expertise is much more in the further down in the machine, obviously in the assembly sort of translation level.
Okay.
One question I had back to the actual software tool. If you're not using something like this, how easy is it to kind of decompile code and be able to extract someone's potentially valuable assets out of their compiled code? I mean,
if you use no protections at all, if you're just writing code, just normal C code with no thought to this at all, it's basically trivial. I mean, you can do an object dump on it, and you can just look in the string section of the code. I mean, if you do, I mean, you can do a little bit yourself. I mean, certainly, you can do some crazy sort of algorithms in your code, and then you can grab sort of one byte from an array somewhere, one byte from an array somewhere else, and do some math in your code to do that. And so you can certainly bake your own thing there. But of course, that only protects, from seeing what's going on to a certain level, but it certainly doesn't help you if someone tampers with your code. Like if later you have like a check versus like a password or something, like if the password is X, do this or whatever, someone can easily find that if check and just change it to, from an equals to a not equals in the assembly, change a byte and, bypass your any checks that you have. So let's say you're writing maybe something for, a POS terminal or something. It'll be relatively easy for, once someone gets their hand on it to get a little worm or a virus to land on that POS terminal and modify some code. With some more advanced protections, you can make it much harder for them to do something like that, especially if something's dynamically changing. It makes it much harder for them to do mount that sort of attack.
Well, the attacks that we've heard of recently where stores, I mean, you bring up POS systems where credit card readers and processors themselves have been compromised and shipped to stores. Sounds like something like this is going to become that much more important that developers start using it.
Right. I mean, this is not, again, it depends on your use case and your threat model, right? And obviously this is one of among many layers of defense in depth. I mean, this is obviously not Fort Knox level security. Certainly there are things we have coming down the road in hardware with some Intel processors, starting with Skylake and SGX, the software guard extensions technology that really give you a hardware trusted execution environment. The primary challenge there is that those things aren't going to be ubiquitous across all, hardware platforms for some time until everyone upgrades to those or later. So until then, as developers, we still want to be able to deploy, software that we can have some assurances, isn't being tampered with to a lot of customers that don't have that latest hardware. And so that's where Tamper Protection Toolkit really comes into play.
Right.
Okay. Well, I think that might be all the questions I have for you, Mark. Jason, do you have anything else?
No, I don't think so.
Okay. Mark, is there anything else you wanted to share? Any more links to the website or just instructions on how people get started using the toolkit if they're interested?
Well, I think the website links are probably going to help you out a lot. I mean, sort of as a general thing, we're definitely, just in general, at Intel, definitely looking for people with software expertise and, deep language expertise. Unfortunately, we find more and more in sort of like universities and stuff that there's a lot of, higher level languages like Java schools and things like that where, they're great for developing applications, but we find that a lot of people don't understand how the underlying machine works because they don't have to deal with, things like memory and pointers as much. So definitely, for those people out there, who are looking potentially at a software career, do take a look at the jobs available at Intel because we are looking for people with, good expertise and good background in software.
It does seem like universities are not teaching C++ as much as they should be these days, which is a real shame.
Or from the sound of it, assembly.
Yeah, or just how the machine works in general. And I understand, I mean, a lot of it, they're advertised, create an app or something. And, so that's great and all, and I'm sure there's a great market for that and there's a need for that. But certainly for the kind of things, the problems we want to solve sort of at Intel, an understanding of sort of the underlying machine, and not just C++, but, C++ help, C++, assembly, any of those languages will get you on sort of that track to know what's going on under the hood.
Right. Okay. Well, Mark, thank you so much for your time today.
All right. Thanks for having me, guys. Appreciate it.
Thanks for joining us.
Thanks so much for listening as we chat about C++. I'd love to hear what you think of the podcast. Please let me know if we're discussing the stuff you're interested in, or if you have a suggestion for a topic, I'd love to hear that also. You can email all your thoughts to feedback@cppcast.com. I'd also appreciate if you can follow CppCast on Twitter and like CppCast on Facebook. And of course, you can find all that info and the show notes on the podcast website at CppCast.com. Theme music for this episode is provided by podcastthemes.com. At CppCast.com. Theme music for this episode is provided by podcastthemes.com.